Good morning, dear teachers, judges, and my dear friends. I'm Satila Hansanen, the host for Team Chemists, and we are here to talk about interactions between molecules. There are two types of interactions. They are primary interactions and secondary interactions. Now, we are going to talk about these two interactions. First of all, primary interactions. And now, it's your turn, Aparna.
Thank you, Sachila. And now I think you all will be interested in getting to know about ionic bonds. So I'm Aparna Sandhani and let's talk about ionic bonds. What is an ionic bond? Ionic bond is the electrostatic force of attraction between cations and anions, which are formed from the complete transference of one or more electrons from one atom to another atom. You may think how ionic bonds are formed. Let me tell you. Ionic bonds are formed when metals react with non-metals. As an example, if we consider sodium chloride, sodium is a metal and chlorine is a non-metal. Sodium gave an electron and become the cation, while chlorine gave that electron and become the anion. The bond formed due to this transference of electron is the ionic bond. There are two factors affecting the ionic bond strength. They are the charge of the ion and the size of the ion. From the charge and the size of the ion, the more influencing one is the charge. Now, Vindi, now up to you.
Thank you, Aparna. I'm Navinda Devasrendra to speak about covalent bonds. Okay, so what is a covalent bond? This is a type of chemical bond that involves a sharing of electron pairs between atoms. These electron pairs are known as shared pairs or bonding pairs, and the stable bonds of attractive and repulsive forces between atoms when they share electrons is known as covalent bonding. Well, there are few properties of covalent molecular compounds, so let us see those properties. First of all, melting points and boiling points are low. Low enthalpies of fusion and vaporization. Covalent molecular compounds are softer, brittle solid forms and they are poor in electrical and thermal conductivity. Furthermore, if we talk about covalent bonds, are there any classifications? Of course, yes. It is classified as according to the number of electron pairs shared and the mode of overlapping. Moving on, according to the number of electron pairs shared, covalent bonds are classified into three types as single, double, and triple. And when we categorize in accordance with the mode of overlapping, there are two types as sigma bonds and pi bonds. Now it's your turn, Radhipa.
Thank you, Navidi. I am Radhipa Alice and I am going to present about dative bonds. Dative bonds. What are dative bonds? In a molecular ion, dative bonds are formed when atoms with empty orbitals interact with a lone pair of electrons. The dative bonds can be denoted by an arrow. The arrowhead is pointed to the electron deficient atom. Then look at these examples for dative bonds. First one is ammonium. Second one is reaction between ammonia and boron trifluoride. And third one is aluminium chloride. Now it's your turn, Tashini.
Thank you, Radhika. I'm Tashin Sirivardhana and today I'm going to talk about metallic bonds, where the electrostatic attractive forces between the delocalized electrons gathered in an electron cloud and the positively charged metal ions forms metallic bonds. The binding energy of metallic bonds are less than both ionic bonds and covalent bonds. These metallic bonds are only present in one state, and that is the solid state. The metallic bonds depend on two factors. First one is number of electrons, which means when more electrons are decolonized, it will result in more strong bonds. And the other point is the packing arrangement of atoms, which means more closely packed atoms result in stronger bonds. These metallic bonds cannot be broken even though they are heated up to a melt state. But instead of breaking these, they are weakened when they are heated. Here I must say something. Due to the delocalization of electrons around positively charged nuclei, the metallic bonds explain many properties. Some such properties are electrical and thermal conductivity, malleability and ductility, high melting points and high boiling points, luster and high reflectivity. So, where do these metallic bonds occur? These metallic bonds occur in ions of same metals, ions of different metals, pure metals, alloys, and metalloids.
And now we are going to head over to secondary interactions. It's your turn, Upek.
Thank you, Sachile. I am Upek Kutsal. Now I am going to talk about reactions. First of all, let me give a small introduction for what is dipole. A polarized molecule having partially negative and partially positive poles is called a dipole. For an example, we can consider a single molecule of hydrogen fluoride. Now I will explain you what are dipole-dipole interactions. The dipole-dipole interactions can be known as the interactions between a negative pole of one molecule and the positive pole of another molecule. Dipole-dipole force is not a chemical bond, and the strength of dipole-dipole interactions are greater than van der Waals forces. The dipole-dipole interactions depend on the shape and the electronegativity difference in molecules. Following are some examples for dipole-dipole interactions. Now it's your turn, Hassan.
Thank you, Upek. I am Pasan Samar Singh and I am going on the topic hydrogen bonds. What is a hydrogen? What is a hydrogen bond? Let's see. It is a specific type of dipole-dipole interaction occur between nitrogen, oxygen, fluorine, partially negatively charged hydrogen atom interact with partially positively charged nitrogen, oxygen, fluorine atoms and form hydrogen bonds. Hydrogen bonds can be intermolecular or intramolecular. Due to the shape of the molecule, the electron pair geometry, and the environment present, the energy of the hydrogen bond varies. This makes them somewhat stronger than van der Waals radius, van der Waals interactions, and somewhat weaker than covalent and ionic. H-bond hydrogen bonds present with both inorganic molecules such as water and organic molecules such as DNA and protein. Back to you, Tashini.
Thank you, Prasan. London forces. The interactions between non-polar molecules and atoms are described as London forces. These forces are occurred due to the random motion of electrons within the atom. Generally, these forces are known to be the weakest forces among all the other molecules. So, where do we find these forces? These London forces can be found in between halogens, noble gases, and non-polar molecules. At the time when the polarizability increases, these forces become stronger. Not only that, but also when the mass and the surface area is high, these London forces become stronger. And back to you, Pasan.
Thank you, Tashini. Ion dipole interactions. Ion dipole interactions results due to the electrostatic interaction between charged ions and polar molecules. The positively charged ion or the cation attract the partially negatively charged pole of the polar molecule, and the negative ion or the anion attract towards the partially positively charged pole of the polar molecule. They most commonly occur when ionic substances dissolve in polar solvents. The best example is dissolving of sodium chloride in water. When the charge of the ion increases and the dipole moment of the polar molecule increases, the ion dipole interactions also increases. Then, now it's your turn, Vidara.
Thank you, Pasan. I'm Vidara Sanuj. Today, I will be giving an explanation about ion-induced dipole interactions. A nonpolar molecule may be polarized by the presence of an ion near it. That is, it becomes an induced dipole. The interactions between them are known as ion-induced dipole interactions. The strength of these interactions depends upon the charge of the ion. So, now let us consider further facts about these types of interactions. An ion-induced dipole force occurs when an ion interacts with a nonpolar molecule. These interactions occur between a fully charged ion and a temporarily charged dipole when an ion interacts with a nonpolar molecule. Dissolving of potassium iodide with iodine solution is an example for these types of interactions. So, back to you, Sachila.
Thank you, Vidara. And now we are going to talk about dipole and induced dipole interaction. A dipole-induced dipole interaction is a weak attraction that results when a polar molecule induces a dipole in an atom or in a nonpolar molecule by disturbing the arrangement of electrons in the nonpolar species. Dipole and induced dipole bonds are those electric bonds that exist between a molecule with a permanent dipole moment and a molecule in which a temporary dipole moment has been induced by the other molecule. A common example that can be seen is hydrogen chloride. That was all we have to talk about interactions between molecules. We all hope you got some interesting facts about it. Now, we've reached the end of our presentation. Thank you everyone for your observance and presence.
Okay. So please get the first slide of your slideshow. Okay, keep the first slide. Yes. Now, if there's any team performance, you can. Okay. Now it is up to examiners. Satita, can you start? We can ask questions from the students. Sajida, we can hear you.
Yes. It's the students. Your topic is primary and secondary interactions. Your topic belongs to the last part of the lesson number 2, structure and bonding. I will show you my question.
Yes, it's visible.
Yeah. My question is based on the secondary interaction. You explained well about that. I think this will be very easy for you. Iodine is a non-polar molecule slightly soluble in water, but I2 dissolves well in potassium iodide. So you just have to explain this phenomenon.
Yes, that's the question. Yes.
Ion-induced dipole interactions.
Have to
Yeah.
explain it.
Can you explain, please?
When the iodine dissolved in Ki, the Ki, the all Ki also consists ions, and when iodine is I2, it's dissolved in Ki solutions. The iodine to I2 molecules get ion-induced side polar molecule polar nature and interact with the negative ion of the negative ion of iodine in Ki solution.
Yes, Puta, you tried a bit to answer my questions. Ion-induced dipole interaction is there, but when you are explaining it like this, you can explain it like this. We know that iodide ion, I minus ion can induce a dipole, right? On an iodine molecule, I2 molecule. So the positive pole of induced dipole interaction with iodide can combine with I2 forming I3 minus. So that's why iodine I2 dissolving Ki more than water. Water is just a polar molecule. And one more thing I want to ask from you. Can you tell me the color of iodine when dissolves in water, and when iodine dissolves, the color of the solution when iodine dissolves in CCl4? What are the two colors? I think you can give me the answer for this question with your O-level knowledge or O-level science knowledge. Color of the solution, iodine in water, and color of the solution when iodine in CCl4.
Yes, anyone can answer. 5 students, then basic question, O-level question. So you have all done your O-levels. Yes, Hasan.
Yeah.
Satila, can you just give your answers? No, okay.
Do you remember the colors?
Just
Sir,
give
is
your
it Yes, sir.
Yes, yes, answer it, no better. Okay, panic when
Brown color. Brown
Brown
color.
color for which solution?
When iodine dissolves in water.
Okay, the other one? Good.
The other one you mean like Ki, potassium iodide.
No. Iodine is CCl4. Carbon tetrachloride, when iodine dissolves in an organic solution. You can't remember.
Madam, what are you asking from us?
The
Could you repeat
color
the
of the
question?
solution when iodine dissolves in CCl4, organic solution. You get two colors for these two solutions.
Okay, madam.
Okay.
Can I answer?
Yeah, sure.
Is the answer violet?
Yeah, good. The answer
Thank
is
you.
correct, violet. This is very important thing. You should know these things. The basic knowledge you should get from your O-level science book. So very good. You all tried well for my question. So you can move to the other questions.
Yes, Shavindra, can you ask your question?
Yes, sir. Thank you. I'll be referring to ionic interactions you were talking about. So you all said in your slides that ionic bonds are formed between metals and non-metals. So my question is there any possibility in forming ionic bonds between non-metals and non-metals? Did you all hear me?
Madam, could you repeat the question again?
Yeah. So you all were talking about ionic bonds in your slides. It was the first slide, as I remember. So you all said that ionic compounds, ionic interactions are formed between metals and non-metals. So my question is there any possibility in forming ionic bonds with non-metals and non-metals? Is it clear?
Yes, madam.
So now students, you should answer. Okay, the time taken to give the answer also will be considered here.
Okay, sir. Answer is no any probability to form a ionic bond when non-metallic molecules.
Sorry, I couldn't hear you.
There isn't any probability to form ionic bonds in between non-metallic molecules.
Your answer is wrong. There is a probability in forming ionic bonds in nonmetals and nonmetals. For example, it's ammonium chloride. Ammonium ions and chloride ions are joined to form ionic bonds. So your answer is wrong.
Okay, it's okay with that. So we can move to the next question. Pinsara, can you ask your question? Keep the slide here. Yes.
My question is based on hydrogen bonding, and it's relevant to the resource book, chemistry resource book. So we all know that electrostatic interactions between hydrogen atom with a partially positive charge and an electronegative atom with a partial negative charge is called hydrogen bond. So my question is it necessary to have an electronegative atom with a delta negative charge bonded to a hydrogen atom in order to form a hydrogen bond?
Sir, could you repeat that question again? I wasn't clear about it.
Sure. Is it necessary that the electronegative atom with the delta negative charge is bonded to a hydrogen atom?
Yes, students should answer at the same time. You can't get any time period. You can think it, you can discuss it, you can give your points. You should give your points. Okay, you can think, you can take the time. So anyone is willing to answer? Yes, Sachida.
Because of the difference in electronegativity, the H atom is able to bond, I guess. Yes.
It's a yes or no question. I mean, if it's yes, give an example. If it's no, it's okay.
Yes or no?
Yes, sir.
Yes, Pinsara.
Well, it's not necessary that the electronegative atom with delta negative charge is bonded to hydrogen atom. I mean, it could be delta positive atom too. Like hydrogen atom could be like delta negative. So I will give you an example. It's in the resource book actually. The example is hydrogen bonding between H atom or hydrogen atom of CH3Cl3 and O atom of acetone. It's actually newly added point in the resource book.
Sachita, can you comment on that also, Sachita? Is it in the new resource book that hydrogen Ca3Cl? Pinsara, can you explain it furthermore? Just
Yeah,
that.
I think, please
Yeah,
can you
Sachita.
explain this? I
Yeah,
didn't
Sachita, you can explain. Yes, Sachita, explain.
I didn't get that. Please can you explain? Tell me
Yeah,
the
yeah,
question. Yeah.
yeah. Pinsara, try to explain it.
Yeah, it's like this. We when hydrogen bond is forming, usually let's take an example as water. Hydrogen bonds between water molecules. Usually, oxygen atom in water is delta delta positive, while hydrogen is the delta negative, right? No,
Yes, sir.
yeah. So no, oxygen is delta negative while hydrogen is delta positive. That's what usually happen when like water or acetone or other compounds
Sir, excuse me,
form
sir.
hydrogen. Sure, ask.
Sir, you're telling that oxygen in H2O atom is
Mm-hmm.
delta negative, right?
Yeah,
And H is delta positive.
yeah,
Okay, sir. Thank you, sir.
and it's not necessary that every time delta hydrogen atom should be delta positive. Like there are instances which hydrogen atom becomes delta negative while the other electronegative atoms become delta positive. Such instance is when we are mixing CH3Cl with acetone, because oxygen atom in acetone, uh, no, hydrogen bonding between H atom of CH3Cl and O from acetone has the opposite way of forming the hydrogen bond. Just refer the teacher's resource book. It's in there in page 80, which belongs to chemistry unit 2.
Okay, okay. Now it is clear. Students can refer it furthermore if you need any clarifications.
Yes,
So
I think it's in page number 82. So student, you all can refer that.
yeah. So we are asking from the syllabus. So that is correct. Okay. So we are going to wrap up the question session from here. So students, you have faced well. So I'm going to keep you in the waiting room, and then we'll be taking back you to evaluate the final marks. Okay. It is the time for your performance. Okay, it was a nice performance, really good. So I'm going to reveal the final marks for your session. So team 4, you are presenting on the primary and second interactions with us. So it was a great presentation. And finally, after discussing with all the examiners, they have revealed their final marks. So I'm going to give the average mark out of that, all the 3 examiners. So it is 20 out of 25. Okay, you have taken 20 out of 25 marks for your entire performance. Now our examiners will comment on your performance, so you can get some comments and then try to make everything perfect when you are reaching to a university level presentation. Okay, that's our target. Okay, Sajida, you will start.
Yeah, thank you, Dulan sir.
Yes, we can hear you. Yes.
Good morning, Dulan sir. Thank you. So, dear students, nice to see your faces. I'm really happy to see your faces. We are willing to see you all. In previous years, we did such type of presentations live at the classroom. I was an examiner there, so Dulan sir normally invite me regularly for this session. So thank you, Dulan sir. Dear students, when we are marking, so according to our criteria, there are 5 points. These are the points. Accuracy of slides, we consider these points when we are marking. Accuracy of slides, teamwork, communication and organization, power of presenting and time management, and Viva, that means answering the questions, creativity, overall quality and the team spirit. These 5 points were considered when we are marking. According to the criteria, according to my marking scheme, you all got 20 out of 20. You all did really well. I really appreciate your effort, and you have practiced well. You have done rehearsals before the presentation, before presenting, and the problem was in the answering the questions. I think you all answered only 1 or 2 questions, but I should appreciate you. Some of you really tried to answer the questions, answering by questions also. And for the accuracy of slides, I gave 5 marks, and you have got highest marks for the teamwork, communication and presenting, teamwork, communication and organization. And actually this is really good. As a problem, when you are doing a presentation, when you are making slides, please do not use so many animations that will disturb you audience. You should use, that's really good. Animations are really interesting. When we are making presentations, when we are making slides, we think that our audience will attract for the animations. That's right, but too many animations will be disturbed to your content. So that will be a very bad fact for revealing your content, because your content will not highlight because of that animation. And also the background color of the slides should be light. Better if they were light, then your content, your letters, the letters will be highlight. That is the only problem in slides. Your presentation flow is nice. There were no external forces, and I should appreciate your performance you did at the end. As the young students, you should do those things in this staying period at home. Working with books, working with papers, working with online sessions will be really boring. So your performance was really good. I felt that very much. Thank you, dear students, and good luck for your future studies. Continue your presenting skills. This this presentation sessions will be really helpful for your higher studies. Good luck for your future. Thank you, Dulan sir, for the opportunity.
Thank you, madam.
Okay, now the next time is let's move to Pinsara. Pinsara, yes.
Yeah. Your to be honest, your presentation was like good, so good. I gave 5 out of 5 for both accuracy of points and teamwork plus communications. And so point wise and communication wise, it was the best. Like you guys are so active, and like it was very interesting to watch your performance. So when it comes to the Viva answers, it can't say it's not great, but it is like you can improve it more. And when like we gave marks to power, I gave marks to power presentation as 4 out of 5 because like as teacher said, Miss said, you could have reduced the animations in the slides because it's like very disturbing sometimes when it's too much of animations. Otherwise, it was great, and creativity was also best. Like I gave 5 out of 5, and I gave only 1 out of 5 for the Viva session because you could only answer the KI question correctly, and also everyone of you turned on video while answering or explaining. That I didn't saw that I didn't see that in other presentations, so that was great. And finally, yeah, overall performance is great, like awesome. Thank you. Thank you,
Okay.
guys.
Yes, thank you, Pinsara. So next time, Shavinda, finally comment on their performance.
Thank you, sir. So I like to say your performance was really awesome compared to the other two. The host did an amazing job, and the presentation skills were excellent of all the group members. And I saw that we could understand that you all have done a good rehearsal, and we appreciate it highly. The doubts I saw were those were mentioned before by the two examiners also, and I saw this, that the font size of your slides, you should have considered about it more. And there were external sound defects while doing your presentation, but you all managed it well. It was fine. So the other two examiners gave out their opinions on the defaults they saw also. I agree with them. Finally, it was a brilliant performance, and yeah, thanks for the entertainment session. It was really awesome. So according to the criteria, I've given you marks for accuracy of slides and points and slides. It's 4 marks. For both teamwork, communication, organization, and presentation skills, I've awarded 5 marks each because you all did a very good job in it. And the Viva session, you all got less marks because you all didn't attempt to 2 questions, just 1 question. But it's fine. You all can just improve your knowledge on the sides which you're talking about and give answers. I just given 2 marks for Viva, and creativity and overall quality, yes, you all got 4 marks because you all did a great job. So finally, I'd like to say that once you enhance your talents more, you all will shine more. Thank you. And thank you, sir, for inviting me.
Yes, yes.
Thank you,
you,
madam.
Shavinda. Yeah. Okay, Buddha. So we are going to finish the session from here. So I would like to thank all examiners and my dearest Dula Putala, and to present. You have done a great job. It's wonderful, really amazing. So it was the first experience that you have taken in your life, I think. So try to get it as an experience and keep it as a experience in your mind, and then when you are reaching to your university level, try to perform very well. Just keeping these things in your mind. Okay, so we are going to wrap up the session, and we want to move to the next team. It is team 1. So we are going to finish this session from here. Thank you. Have a nice day, Buddha. Okay.
Thank you, sir.